Hello everyone. In this video, I would like to discuss the problem D of educational code forces round 161. In this problem, we are given that there are n monsters, and the ith monster has attack value equals to AI and defense value equals to DI. Now there will be n rounds, and in a particular round, what will happen is each monster I will provide a damage of AI to its closest live alive monster to the right and to its left. And after this round, let's say there is a monster J, then the total amount of damage received by this monster, if it is strictly greater than DJ, then this monster will die in this round. So for each round you will have to calculate the number of monsters that will die in that round. Okay, so let us understand this sample test case. First sample test case. So we have 5 monsters and their attack values are 3, 4, 7, 5, 10, and defense values are 4, 9, 1, 18 and 1. Okay, so in the first round, round 1, what will happen is who will die. So first die the the damage first monster will get is only from the second, right, from the second monster. And how much the damage value the first monster will receive, it will receive exactly 4, right? So the first monster will not die in this round because 4 is less than or equals to 4. Okay, because the damage value should be strictly greater than the defense value, right? Then only the monster will die. So first will not die. Let's see if second monster will die or not. The total damage received by second monster is 7 from first monster and from third monster, that is 7 plus 3 10, and as 10 is greater than 9, the second monster will die in this round. So first will not die. uh, the monsters die in this round are 2. Third monster will also die because damage received is 4 plus 5, that is 9, and 9 is greater than 1, so third will also die. Third monster will also die. Fourth, let's see if fourth die or not. Fourth, total damage received by it is 10 plus 7, that is 17. 17 is less than equals to 18, so it will not die. And fifth monster, the damage received by fifth monster is only from fourth monster, that is 5, and as 5 is greater than 1, as 5 is greater than its defense value, the fifth monster will die. Okay, so fifth will also die. So in this round, answer for this round is 3, right? And the remaining monsters are first and fourth. Here are their attack values and defense values. Okay, let's see what will happen in round 2. In round 2, we can see that the first monster, this 3, 4, the first monster will die. Why? Because it will receive a damage value of 5 from the second monster, and as 5 is greater than 4, it will die. Okay, so first monster will die in this round, and the remaining is the fourth monster, and here are its damage and attack values. Now as it is the only monster remaining, so it will be still alive in further rounds. So answer for this particular test case is, for first round 3 monsters died in this first round. In the second round only one monster died, and for further rounds 0. Okay, so these are the output values we need to return for all of the 5 rounds. Okay, now let us see how we can solve the problem for larger test cases. The brute force way is, what we can do is, for each round we can see just for each round we can see if the particular monster the total amount of damage received by a particular monster from its left and right is greater than or greater than the defense value, then it will die, otherwise it will not die. And if it dies, then we can remove this element, remove this monster from this list. And then, so this in this way we can check all the monsters for each round, right? So it will take order of n square time, but if we see the constraint of our problem, we need to solve it faster. So what we can do is, we will maintain a queue, right? We will maintain a queue, and in that queue we will insert which monsters will die, right? Which monsters will die. So we will store let's see the code for better understanding. Why is it not showing the code? Okay, let's see it. Okay, so what I have done in code is, so in this code what I did is, I initially took 2 vectors a and d. Here I just took the input vectors, the defense values and attack values. Now I will take a queue, right? Inside this queue I will insert 4 integers, right? So what this integers will represent is, so basically this tuple will represent that jth monster can die when its left and right monsters are I and k, and this jth monster will die in round number that is equals to this round number. Okay, and in this array, visited array, what I will store is, I will store the time, the round number when the ith monster will die, and this set of indices, this will contain the indices of the monsters which are alive at the current moment of time, right? Okay, so at the first for the first round, I will do is, I will just insert all of the indices in the indices set, because initially all of the monsters are alive. Now for the ith monster, I will calculate its damage value, right? So if damage value is greater than I, then I will just push this monster along with its left and right neighbor, right? And the round number, so initially round number I am taking 0 index, so the first round I am taking it as 0, and I am taking a vector answer. Here I will store, for each round, answer of I will represent the total number of monsters that will die in the round I. Okay, now I will just run the while loop until queue is not empty, and here I have just got the first element of the queue, right? And I j k, j is the monster which will die in this round, and I and k are its left and right neighbors, and this is a round number. So if visited of j is not equals to empty, what does it mean? It means that this jth monster has been died earlier, so I will just continue. Otherwise, if I not equals to k means left neighbor exists for this jth monster, and visited of I less than round number, what does it mean? It means that this ith monster has been died before this round number, right? So if this monster is not alive at the current round number, then it is sure that it will not provide that damage, so we can just continue. And similarly we will check for the right neighbor also. If the kth monster is if the kth monster is not equals to -1 means the kth monster exists for this round, right? And if vk is less than round number, it means that it has been the kth monster has been died earlier before this round number, so we will just continue, right? And if any of these conditions is not satisfied, it means that the jth monster can die in this round, right? So we will increment answer of round number by 1, and we will erase the jth monster from the indices because it has been died in this round number, and we will update visited of j equals to round number, that jth monster has died in this round. Okay, now what I will do is, as the jth monster has been died, right? So what I will do is, I will just jth monster has been died. Now from the remaining set of indices, right? Let's say before this there is I, right? And after this, let's say there is kth monster. Now what I will do is, I will check for both I and k whether they will die or not, right? So how I will do is, how I will check this is, I will check the left neighbor of I and the right neighbor of I for I, and if the damage provided in this current round by left and right monster is greater than its defense value, then I will insert this particular monster in my queue. Similarly, I will also check for k, right? So here is what I am doing. I am first checking for the k. If the damage value is greater than the defense, then I will insert in the queue. Similarly, I am checking for the left neighbor also, and if damage value for the left neighbor also is greater than damage value is greater than its defense value, then I will just insert in the queue, right? So this way I am able to solve this problem in n log n time, right? Okay, so this is how I did it. I hope you got the solution. Thank you.